Okay, good morning, Professor David J. De Los Reyes. Okay, my topic for this session, I will keep this session not too long so it will be bored. Okay. My topic for this session will be the power comparison. Power comparison meaning the difference between a direct current power and alternating current power. For a direct current circuit, the figure will be something like this. The circuit is just simple. It just comprises a battery and the load are lights. It's just simply lights. The designation for the lights is the load is simply R. So if we try to bring out the formula for taking the power for DC circuit, this will be the formula. It will be the square of the current times R, the product of voltage times current, the square of the voltage over R. The voltage of the source is just B, the current consumption is just I, and the load is designated by R, which only comprises lights. So for DC circuit, the only load that is existing are actually lights. Okay, it could be light bulbs, but they are DC light bulbs. It's not AC light bulbs. So the current square times R, the voltage times the current, the square of the voltage over R is actually the power under DC circuit, and the unit is watts. The greater or the bigger power rating is designated kW, meaning kilowatts, 1,000 watts. Or the more bigger than the kilowatts will be M, then W. This M here represents mega, meaning 1 million watts. So if you hear the power rating, it is just simply watts, or kilowatts, or megawatts. Those are the power rating for a DC circuit. Okay, actually for cell phones, there is the so-called small letter M, then watts. Mainly watts, because the consumption of cell phones is actually, it's not so big, so that's why it's milli. Milli is 1 times 10 to the minus 3. Oh, so if you hear a milliwatt, simply watts, or kilowatts, or megawatts, those are the power rating for a DC circuit. But DC circuit is not so big, so actually we could not even reach the kilowatt and megawatts maybe. Okay, so we'll just limit ourselves to milliwatts and watts for DC circuit. And these are the formulas. Okay, the more complicated thing is for AC circuit. Our actual circuit for what they call this, for household thing. Because for household thing, there are 3 types of loads. It will be the lighting load, which is designated by R. There are the so-called motor loads. Motor loads is just like the pumps or the pumps for fountain, something like that. Those are considered motor loads. And the other loads are actually condensers. But for houses, it's not so flooded with these condenser loads. It could be companies maybe. Because in a company, there's the lighting load, there's the motor load, and the condenser load. They needed this condenser load. Okay, I just placed this one meaning to say that in AC circuit, there are three types of loads. It will be lighting load, motor loads, or condenser loads. Okay, let's discuss the power rating for what they call this AC circuit. There are three types of power, or yeah, actually three. The designation for the first power is actually the so-called letter P, which is true power, and the unit of that is watts. And the formula for taking the value is this one. The product of the square of the current times R. Meaning whatever the current that will come out here, we multiply it by the total resistance of all the lights, represents the true power. Okay? For the motor loads and the condenser loads, we call that reactive power. And we designate that with a capital letter Q. And the unit of this is actually bars. B-A-R-S. Bars. And the formula for taking the value will be the square of the current times the inductive reactance of the motors. Or it could be the square of the current times the capacitive reactance of the condensers. Condensers meaning it's just like a capacitor. Because there are motors in which if you try to overexcite them, they will act like a capacitor. That's why we call them condensers. Okay? That's the second power. The first one is letter P. It is true power. The second one is Q. We call it the reactive power. And the biggest power under AC circuit is actually designated by capital letter S. And we call this apparent power. And the unit of this is volt ampere. Okay? The greater values for AC circuit, the true power is watts, right? The reactive power is bars. And the apparent power is volt ampere. So if we try to place here a letter K, okay, that will now be kilowatts. That's why when the utility company serves us the so-called bill for every month, okay, the total power we are paying to them is actually the one in kilowatts. Okay? It's not the kVA, it's the kilowatts. If we try to put a letter K here, that will now be kilobars. Okay? For the total apparent power, okay, if we try to put a letter K here, that will now be a kVA. That's why sometimes, if you try to see the markings of the transformer on the post, we often see a kVA rating over there. Okay? So that kVA rating represents the total apparent power. The importance of the total apparent power is that it is the power in which we could determine the total current consumption of any household. Okay? So you often see the transformer up on the post with the rating kVA. Okay? And supposing we will replace this by M, capital letter M. Okay? This is a bigger power ratings. This is megawatts, million watts. This is million bars. And this is million volt ampere. So actually, power plants are actually power plants. The power rating designation of power plants is in the designation mega volt ampere, because they are giving million amperes to customers just to serve us electricity. So instead of the kilowatt, it is the so-called million volt ampere. Okay, that's it. So AC circuit is more complicated. That's why I discussed the true power, The apparent power and the apparent power. The one we are paying to the utility companies is this one. It is the true power. We are not paying for this one, and we are not even paying for this one. It is only the true power that is we are paying to the utility companies. That's why if you say watts or kilowatts, okay, that's our consumption. Okay, good evening from Los Angeles.